The method we're going to talk about is what we call systematic innovation toolkit, and the idea behind it is that we can take any kind of problem situation or opportunity situation and systematically work through a series of steps to understand what the problem is, because very often defining the problem is much more difficult than solving it, and then produce inventive solutions. Now, the method's quite new, and the chances are that you haven't seen it before, and that's perhaps uncomfortable for some people, because it's actually a method, or the roots of the method go back quite a long time. In fact, it's one of the biggest studies of creativity and innovation ever conducted. As you can see from this slide here, quite a few companies are beginning to use the toolkit now. Big names from across a whole range of different industries, and they're all using the method and generating some real successes with them. And in fact, for a long time it's been a problem that companies aren't prepared to share some of those successes with other people. We're going to have a look at the method rather than what they're doing, and what I thought I'd do was start the journey by looking at why I think the method is really important. And the roots of that really start with the idea of the way systems evolve. That's systems in any form. And what we'll very often see is that we'll get this characteristic S-curve shape. And the idea behind this is that over time, when we first work out how to do something, it's quite easy to improve that thing. But then after a while, it becomes more difficult to do it. And by the time we're at the top of the S-curve up here, we're in what we would call typically the continuous improvement paradox. We have to put more and more effort in to get less and less benefit out. And this is the part where the systematic innovation methodology really has its power, because what it's trying to do for us is recognise that when systems hit the top of this S-curve, they are hitting fundamental limits. So this continuous improvement paradox, or a law of diminishing returns, is eventually going to cause us a problem. It means one day we're going to set ourselves a target, and that might be a business performance target or a performance of a product or a service, and that target's going to be inconsistent with the capability of the system that we've got. And what that means is we're going to have to find some way of changing the system. Now, that doesn't necessarily mean throwing away what we've done and starting again. What it does mean is that something in our system has hit its limit, and we need to find what that something is. What I'm going to do now is look at the three main tools that are going to help us to identify where systems have hit their limits, and more importantly, help us to generate solutions to those problems. The first way is one that's got an idea in it which is perhaps a little bit difficult to believe at first, but one of the big ideas in the method is that someone somewhere has already solved your problem. And therefore, if we believe that, and I'm sure it's difficult to believe at first, but if we can believe that, the real challenge then becomes finding the ways that other people have solved the problem. Where are those people that have already solved the problem that we've got? One of the things that we're going to do then is the method will take us in a helicopter, and it will allow us to see the rest of the world and see where these solutions might be. And a simple way of illustrating that is to think about this glass of water here, and the idea in the slide of a problem that I've been given, which is I want to get the water out of the glass. And so how might we typically look at that problem? Well, probably when we've understood what the problem actually is, we'll get a group of experts together from within the company or within the team, and we will brainstorm ideas. So very quickly we're going to get things like, I'm going to use a pump, I'm going to use a sponge, I'm going to use a straw to get the water out of the glass. And that's great. It's great until somebody finds a better way of doing it, or the ways that we've come up with hit their limit. So one of the big ideas then behind the method is, wouldn't it be nice if we could brainstorm this problem, not just with the experts in our team or within our company, but with everybody in the world that ever had to solve this problem. And in order to do that, the helicopter idea says we need to find other people that have solved similar problems to this one. Well, quite clearly, getting water out of a glass is not a very important problem. And so not many people have had to think of an inventive way of doing that. And so we need to make our problem look like somebody else's. And in this case, the most effective way of doing that is to recognise that the get the water out of the glass problem is one of moving a liquid. So get the water out of the glass, move a liquid. Just by making that translation there, I've now got a problem description where just about every industry in the world at some time or other has to achieve the function move a liquid. And so what the method researchers have done is been and looked at all of those industries and have asked the question, how is it that you perform this function move a liquid? And if we look at the next slide now, at some of the ways that we can find, we can see that there are nearly 50 different ways of achieving that function. Now the chances are, as you're watching this and looking at those slides, those ways of achieving the function, a lot of the things on the list you haven't heard of before. And the reason for that is because everybody these days has to specialise in their own industry. And what the method is allowing you to do is see what all the other industries are doing. And there's a function database that allows us to see how other people have moved liquids, separated fluids, cleaned things, increased the temperature of things. Whatever function it is that we're trying to perform, the database will give me an access to ways that other people have performed that function. So there's the first way of looking at how we can change our system, move from one S-curve to another S-curve. The second way is a way that gets us to think about trends of evolution. And one of the big differences between what we've done in this method and what you might normally think of when you think of trends of evolution is here we've been deliberately looking for the disruptions that take place when a system jumps from one way of doing things to another way of doing things. Okay. So it's all about the non-linearities in systems, what happens when things move from one way of doing something to another way. And we spend a large part of our research time, and we've got about 25 people researching full-time now, spending that time looking for these patterns. So we're looking at new patents as they emerge. What is it that's happened in this patent relative to what happened before? And what I'm going to put up on this slide here is some of those trends of evolution. In fact, the first one we'll see is the idea that systems are going to evolve in a direction of becoming more ideal. And what we mean by that is give the customer more of the good things and less of the bad things. So more benefits, more function, less cost and less harm, where the harm will be things like environmental issues, waste and things like that. At the bottom of the slide you can see one of the more detailed trends, a trend that we know as space segmentation. And this trend basically says things will start off at the left hand side of the trend and they will evolve across to the right. And so things will start off as solid things, they'll become things with holes in them. First of all one hole, then several holes, and then very small capillary porous holes, and then we'll put something active in those holes. And this trend is, we can see this happening in many different industries, from chocolate bars to jet engines to the soles of your shoes. For different reasons, these systems have all evolved along these trends. Let's have a look at another pair of trends. This one, the next one, is similar in many ways to the one we've just seen. It's called object segmentation this time, and is really a trend that you might think of as doing more with less. and it basically says things start off as solid things, and then we segment those solids, and then we become fluid, segment the fluid, become a gas, segment the gas, and then ultimately end up with a field. And again, we can see many examples of things following this trend, from cutting equipment, where we might think of a saw evolving through to a laser, through to a whole range of different products, cleaning products, for example, a wide range of different things following the system, that trend. The slide at the bottom of the picture then is another trend, surface segmentation. Things starting off smooth, becoming roughened, and then adding active elements. And even this one, though this one might look a little bit odd, it tells us somewhere there's an advantage in moving to the right along the trend. So if I think about an aerodynamic surface, for example, then historically we thought that we need to make those surfaces as smooth as possible to reduce the drag. But if I look at what nature has done in this case, if I look at the shark, there's an animal that is very low resistance as it moves through the water, but it's anything other than a smooth shape. It's evolved a very three-dimensional roughened surface, and we can now see that same idea being transferred into the aerospace industry, into the boating sector. This next trend I'm going to look at is one that's called rhythm coordination, and it's quite an important one. I say that because there are many systems that we can see that are over on the beginning part of the trend. Now, that beginning part says things start off as continuous actions. And give you an example of the trend in action. If I want to clean beer bottles, then a way of doing that is to inject water into the bottles, turn the bottles upside down, the water will come out. Now, that water is a precious commodity, of course, and anything that we can do to reduce the amount of water we require will be useful. And so what this trend will tell us to do is add some kind of a pulsation to the system. The trend tells us somewhere there will be a benefit in moving to the right along the trend. And in this case, what we find is if we pulse the water jet going into the bottle, we can reduce the amount of water we require by about 50%. A substantial improvement for a very simple change to the system. But the trend says there's still more stages here that you've not used yet. And in fact, the next one is quite interesting. It says use resonance. And in fact, if we do that with the beer bottles, if we now find the resonant frequency of the bottles and pulse the water at that resonant frequency, then the bottles begin to resonate. They clean much more easily, and we can further reduce the amount of water required. In fact, if we use resonance, we can probably reduce the total amount of water by 75% now. Now, this trend gives us some idea about how we might use these things ourselves. It's all very well to see that somebody's already discovered these trends. How is that going to help me solve my problem? What we can see happening in this next picture is I've integrated all of the trend information together. This is a picture that we call an evolution potential plot. And each of the spokes on the plot represents one of the trends of evolution. And what I've done here is I've looked at a patent. Or a design solution, and I've compared my solution with the trends of evolution, and I've asked the question, how far along each trend am I? And what the picture then gives me is an indication of this is where you are versus this is where you could be if you took advantage of the best practice that everybody else has discovered from other industries. So the idea of evolution potential, all of that space around the plot that you haven't used yet, is opportunity to improve the way that you design and think about the systems that you're developing. So this example here is one for windscreen wipers in cars. Now, you might think that windscreen wiper in a car is a very well evolved product, and in many ways it is. But what this trend picture tells us is that even though the product is quite well matured, compared to a global benchmark, it's still got lots of untapped potential in it. There are lots of trend stages that have not been used yet. And if we're looking to design a better windscreen wiper, a cheaper one for example, or one with less harm, one that lasts longer, then all of this untapped potential is opportunity to evolve the way that we think about the design of these things. Now, one of the big issues with this method is it's very easy to invent new things. In fact, it's something that we find ourselves doing all the time. So I'm not going to try and reinvent the windscreen wiper here. What I am going to do is just move on then and look at the third part of the method, the third most important way of jumping from one way of doing something to another way. And this is the part where we think about contradictions. Contradictions are everywhere, and I think that's a result of the way that the world designs things. We typically think about things as trade-offs. So in this slide here you can see a very typical trade-off, a trade-off between strength and between weight. So I would like to make things strong. So in this case it's a car. I would like to make my car strong, but on the other hand, if I make it strong, typically that will mean that my car is going to be heavy. And so what every designer typically does is says, okay, I'm going to balance these parameters, I'm going to get just enough strength to meet the safety requirements and make my car as light as possible, use the lowest amount of materials as I possibly can to make the car affordable. Now what this part of the method says is someone somewhere has been thinking about these trade-offs and has found a better way of designing things. There are people, inventors, who have said, I want to make the car stronger, but I don't want to make it any heavier. And what the research team for the method has done is looked at those kind of solutions. Those people that have said, I don't want to accept the trade-off, I want to improve this thing and I'm not going to let this thing get worse. What is it that they've done in order to create an inventive solution? Now the method says, if we look at many thousands of different types of solution like this where people have not accepted trade-offs, and we look at the strategies that they've used, we can find that there are a very small number of those strategies. In fact, for this strength versus weight conflict, and as we can see in this slide, there are very few strategies that have been used to evolve an inventive solution. So here we can see 5 different strategies in total. For all types of trade-off problems, and that's what business trade-off problems, cost versus quality is a very typical one there, or any kind of technical trade-off, we can see there are just 40 ways of generating solutions to these problems. Now again, that might sound very surprising. How can there possibly be just 40 ways of solving a trade-off problem? We spend all of our time looking for a 41st way and a 42nd way, but wherever we look so far, we can't find one. So we are saying so far there are 40, there may be 41, there may be 42, who knows. But today there are just 40 ways of eliminating trade-offs and compromises. So one thing we can very simply do is to look at these 40 ways and use them as ways of brainstorming systematically ideas to help us to solve our problems. If we want to be a bit more systematic than that, then this next slide shows what we call a contradiction matrix. And the idea behind this tool is it allows us to directly look at what we'd like to improve, what typically gets worse, see how other people have solved that kind of trade-off and what strategies they've used. And it's a bit more difficult to use this part of the method, but almost inevitably, if you can solve a trade-off in a system using one of these strategies, you can almost guarantee to have invented something. So, what we've just seen are 3 main ways of advancing systems, designing things in inventive ways. Use somebody else's solution, use the trends of evolution, and use this contradiction part of the method. That brings us back then to the whole picture again. So we're talking about systematic innovation, and I think one of the things that's really important to recognise is the idea again of someone somewhere has already solved your problem. So this method has been built from all of those great tools and techniques that are out there that we can see in this slide that enable us to look at different types of problem. And the idea behind the systematic innovation toolkit is pick out the most appropriate of those tools for whichever problem that we've got. Now obviously in this short space of time we haven't been able to look at all of those tools. But for all of them, we can see that they have been built into this overall process. And the idea behind the process here is that we can literally start from a very uncertain initial situation. That's, I've got a problem and I don't know what my problem is, or I haven't got a problem, but I just think I might like to do something better than I'm currently doing it. And then the idea behind the toolkit is, as it says in this final slide, I've got a turbo for innovation. And here we get the idea that all industries are fantastic at what they do these days. They have to be in order to stay in business. So you know your business extremely well. But very often you don't get the time to look at what other industries are doing. So you've got the engine for your own sector, but it's very difficult to see what other people are doing. And that's really what the turbo idea means. That's the thing that gives you the visibility of what the rest of the world is doing. So we've got this turbo for innovation, and the idea that nobody is as smart as everyone. So wouldn't it be nice if you could put all this information in one easy to use, easy to manage package? And that's what we've tried to do with the method. And finally then, the idea of an ideal final result, that things evolving towards this end state where customers get all of the good stuff that they want and none of the bad stuff. And that's really what we're trying to design into the method as well. Be able to effectively work towards solutions in a very systematic, easy to do way, and provide a framework for all of mankind's knowledge, whether it's innovation tools or whether it's ways of getting water out of glasses, whatever it is, provide that framework. So if you want to find out any more, then the easiest way of doing that is to go to the website. There's the address on the slide now. And you'll find there are an awful lot of resources out and about that are free and easy to use. If you see something you're interested in, then we'd be very happy to tell you more, enable you to find out more about the method. Thanks for your time.